The next entry in the toolbar is the Knife tool. In fact, there are two tool options here, the Knife tool and the Bisect tool. We'll look at the Bisect tool in the next video. The Knife tool allows us to create new edges anywhere within the selected mesh. This gives us much more flexibility than other methods such as subdivision and loop cuts. When we select the Knife tool, the mouse cursor changes to a knife symbol, but unlike the previous tools we've looked at, there is no gizmo in the 3D viewport. For the first example, we'll restrict the new edges to within a single face. Each left click of the mouse positions a new vertex, and Blender automatically rubber bands from that vertex to the knife pointer's location, adding a new edge between each vertex we create. To enclose the area, we can either click back on the starting point, or we can double-click, and Blender will add a final edge to complete the enclosure. It also takes the double-click as a sign that we've finished that sequence of cuts and allows us to move the knife to a new location without assuming a new edge should be joined to the previous location. To complete the operation, we need to press the spacebar or the Enter key. Notice that Blender may then create additional edges to optimize the faces surrounding the edges we have created. If we want to cancel the set of cuts we are currently creating, we can press the Escape key. There are two ways to start a knife cut. We can either hold the left mouse button down and drag the pointer, or click and release the left mouse button. Each has a slightly different effect on the cuts produced. Using the drag method, the normal practice is often to start the knife cut in an empty space, dragging the knife over the existing edge. Blender shows a marker where the new vertex will be placed, though as we move the knife, the marker moves too. But when we pass the knife over the second and subsequent edges, the point we pass through finalizes the locations of the first and second vertices. All the points we have passed the knife through will become new vertices when we complete the operation. If we finish the cut in the middle of a face, we need to remember to left-click to fix that point. Otherwise, the final location will be ignored. If we started the knife cut operation by clicking and releasing the left mouse button, the complete cut will appear as a straight line, and all the intersection points will relocate as we move the mouse pointer. To complete the cut, we need to click the left mouse button and then press Enter or the space bar. This straight line is an illusion caused by our current viewpoint, and we can see the actual new edges more clearly when we move to a new viewpoint. We can combine both cutting methods by simply clicking each time we want to fix an intersection point. We can force the cut's intersection of an edge's midpoint by holding down the Shift key while dragging the knife or clicking anywhere on the edge. Notice that the knife only cuts through visible faces. The hidden faces on the other side of the cube remain untouched. If we want to cut through those faces too, press the C key at the start of the cutting operation. We can also cut along an axis by hitting a direction key, X, Y, or Z. Which axis set is used is determined by the transform orientation setting. In the example shown here, we can see a cube that has been rotated by 10 degrees about its y-axis. If the transform orientation field is set to global, then pressing X at the start of the cut will create a cut along the global x-axis, with its origin centered on the knife icon. With transform orientation set to local, then the cut will be along the local x-axis. Another straight line cut option is achieved by pressing the A key. Since the choices available here get a little complicated, we'll demonstrate on a simple plane where one vertex has been moved to create a kite-shaped mesh. Once we've initiated the knife cut by pressing the left mouse button, pressing A creates a white line showing the direction in which the next cut will be made. If we move the mouse pointer, the line will rotate in steps of 30 degrees with its pivot point at the location of the knife cursor at the last mouse click. Angles are measured relative to our current viewpoint. If we press the A key for a second time during the same knife cut, angles are measured relative to the last edge to have been cut. However, there's a problem if we are using this second option. When the latest cut has ended up on an existing vertex shared by two or more edges, Blender has to guess which of those edges we want to measure the angle from. By pressing the R key, we can switch between the possible edges. If we want the rotation to be in steps other than 30 degrees, we can enter the angle we want after pressing the A key. For example, entering A5 will change the rotation to increments of 5 degrees. And if you want to change the step size to some other value during the same cutting operation, just enter the new value. This step size is not retained after we've pressed the spacebar, Enter, or Escape. So the next time we use the A option, it will return to 30-degree steps unless we again enter a step value. If we are making cuts that require exact sizes or angles between edges, then we can press the S key. This displays the lengths of all the potential new edges, as well as their intersection angles. One last key we can make use of when cutting is the Control key. You may have noticed that Blender tends to snap to an edge as the mouse pointer comes close to it. We also see snapping if we are forcing Blender to select mid-points on an edge by holding down the Shift key. We may even have snapping switched on by using the snapping icon at the top of the 3D viewport. We can disable all of these snapping options by holding down the Control key as we move the knife. As you can see, there are many keys that affect the knife cut tool, but we don't have to remember them all, because the status bar is there to remind us of the options available while using the tool. The final entry in the status bar is the angle constraint. Here, we are not only reminded of the key used to activate this option, but it also tells us which mode is currently being used: off, screen, or relative. Notice how the display changes each time we press the A key. And, in addition, it displays the current angle step size. Again, we can see this change as we type in a different angle after pressing A. The knife tool does not produce a last stop panel, but there are some options in the top left corner of the 3D viewport. Occlude Geometry, which is selected by default, controls which faces we can cut through. When it's selected, only faces visible from our viewpoint can be cut. But if we uncheck the box, hidden faces can also be cut. The effect is similar to pressing the C key, except this change remains in place for all future cuts until the box is reselected. Only Selected restricts cuts to only those faces that are previously selected before the cut begins. X-ray, which is also available as a once-only option using the V key, will show the position of edge cuts being made on hidden faces. That is, when we have Occlude Geometry unselected, or we've pressed the C key. The final set of options is shown as the 3 full stops of an ellipsis. Clicking here to display the panel, we can set other controls to be permanent changes rather than the one-off option offered by the equivalent keys. Measurement allows us to always display angles, distances, both, or neither. Angle snapping will switch on angle cuts. It is similar to using the A key. We can choose Screen, Relative, or None. Finally, Snap Increment sets the default angle used if angle snapping has been selected, or we are using the A key without also entering a specific angle. Rather than select the knife tool from the toolbar, we can access it using the K key as a shortcut. But if we use this option, there are no control fields in the top left of the 3D viewport. One last point to remember is that we can use the knife cut to cut through any type of face, tri, quad, or n-gon. So, while the loop cut will not cut through a standard cone because its sides are tris, the knife tool can do this without any problem, and we can use GG to slide the new cuts to any position.